Hello again, everybody. Today we are going to talk about graphing absolute value equations. Okay, so the absolute value of a number can be defined as follows. The absolute value of x, so these bars mean the absolute value, is x if x is greater than 0, it's 0 if x equals 0, and it's negative x if x is less than 0. So what does this mean? So what this means is, let's say we have the absolute value of 3. Well, 3 is greater than 0, so the absolute value of 3 is 3. Okay? Now, if we have the absolute value of 0, that's just 0. If we have the absolute value of negative 3, then that if x is less than 0, so it's negative 3, then the answer is negative x. Well, negative x when x is negative 3 would be positive 3. Okay? So basically what you're doing is taking whatever numbers inside these absolute values and just making it positive. Okay? All right. So, absolute value of 5 is 5, absolute value of 0 is 0, absolute value of negative 5 is positive 5. Now, what does it look like if you graph it? Well, an absolute value equation always looks like a V, like this. Okay? So if you think about it, here's the absolute value of 0, the x is 0, the y is 0. The absolute value of 1 is 1, the absolute value of 2 is 2, the absolute value of 3 is 3, the absolute value of negative 1 is 1, absolute value of negative 2 is 2, absolute value of negative 3 is 3, and so on. So you get this nice V shape right here. And this point right here, that point is called the vertex. Okay, that's where the bottom of the V is. Or if it's upside down, which it can be, and we'll talk about later, then it would be the top. Okay, so what do absolute value equations look like? They look like a V. The base of the V is called the vertex. Okay, we just talked about that on the previous page. The V can be opened up, as it is in this case, or the V can be opened down, as in this case. Now, why is this one opened down? Well, if you take the absolute value of x, that gives you a positive number, but then you put a negative on, that's going to automatically make it a negative number, so it's going to flip this thing upside down. Okay, so anytime you have an absolute value where no matter what it looks like, this one is the absolute value of x, but it could be the absolute, could be the absolute value of x plus 2, or the absolute value of x minus 3 plus 7. All of these are going to be opened up because this is going to be a positive number, okay? This is going to be a positive number, this is going to be a positive number, so it's going to get bigger each time, okay? This one, anytime you have a negative outside the absolute value, it's going to be opened down like this. It's going to be upside down. Okay? All right. Here, let's do this. So when you look at the notes, you're not confused. All right. So we can graph all the other absolute value equations using transformations. So we've done transformations before, but we'll just kind of review them. So here we have, we can move an absolute value up by adding a number to the end of it. So y equals the absolute value of x plus 2 looks exactly like the y equals the absolute value of x, except it's moved up 2. So here's my y equals absolute value of x, okay? And then if I want, if I want y equals the absolute value of 2, or x plus 2, it looks like that. Okay, I moved it up 2. I took all of the values here, whatever that was for absolute value of x, and I just added 2 to them. So this one was 0, I added 2, it's 2. This one was 2, I added 2 to it, it's now 4. And so on. Okay, I can move an absolute value equation down by subtracting a number from the end of it. So if I have my absolute value of x here. Okay, now this one has a -4 on it, so what that's going to do is it's going to move it down 4 to right there. So this is going to be y equals absolute value of x minus 4. It just takes each one of these values here and subtracts 4 from it. So 0 gets moved down to -4. 2 gets moved down to -2, and so on. Now, if I want to move an equation to the right, I subtract a number inside the absolute values. Okay, so notice my -5 is inside. Now, you might think that it's going to move it to the left because -5 is to the left, but it does exactly the opposite of that. So, excuse me, there's my y equals absolute value of x. Now, y equals absolute value of x minus 5 is going to be right here. Okay, now why does that work that way? Okay, so let's take a look at a table. Okay, so if we have this, here's our x and our y. Okay, if I plug in the number 0 here, I get absolute value of -5, which is 5. So 0 becomes 5 right there. Okay, if I put in 5 for my x, then I get the absolute value of 5 minus 5, which is the absolute value of 0, which is 0. Oh, that's that point right there. If I put in, say, 7, well, that would be the absolute value of 7 minus 5, which is going to be the absolute value of 2, which is just 2. Oh, here's 7, and boom, there I'm at 2. So you can see it shifted it to the right here. All this should be reviewed. Kind of a ways ago, but it should be reviewed for you. Okay, if I want to take an absolute value and move it to the left, then I add a number inside the absolute value signs. Okay, so here's my absolute value of x right here. Now, absolute value of x plus 3 is going to be right there. And again, if I look at a table, okay, and I plug in 0, I'm going to get 0 plus 3 is 3, and the absolute value of 3 is going to be 3. And so at 0, I get 3 right there. If I plug -3 in here for x, I get absolute value of -3 plus 3, which is just going to be the absolute value of 0, which is 0. There's my vertex right there. And if I put in, say, -4, well, that would be the absolute value of -4 plus 3, which is going to be the absolute value of -1, which is +1. Well, that's going to be right there. And so it makes that V shape right there. Now I can do combinations of them. So here's my absolute value of x in red. Well, what would happen if I graphed x plus 4 minus, the absolute value of x plus 4 minus 3? Well, this would move it 4 to the left and 3 down. So 4 to the left, 1, 2, 3, 4, and 3 down, 1, 2, 3, boom, right there. There's my graph. Now, if you're not sure, you can always confirm it using a table. Okay, so you get this graph and you're like, I'm not sure that that's right. Well, what would happen if I plugged in -4 here? Okay, well, -4 would give me 0 in here. The absolute value of 0 is 0 minus 3. That'd give me -3, right? -4, -3. 1, 2, 3, 4. 1, 2, 3. Oh, puts me right on the vertex right there. What if I plug in -1? Well, -1 plus the absolute value of -1 plus 4 is going to be the absolute value of 3 minus 3. Well, that's going to be 0. Oh, -1, 0. That's right there. What if I plugged in -7? That would give me the absolute value of negative 7 plus 4. That's going to be the absolute value of negative 3 minus 3. But the absolute value of negative 3 is 3 minus 3, which is again 0. Oh, that gives me that point right there. There's my V again. Okay, now, an absolute value equation can be flipped over by adding a negative to the front of the absolute value. So notice the difference between these two equations right here. Okay, the only difference is that minus sign out there in front of the absolute value. So here's my blue equation here, the absolute value of x plus 3 plus 2. Okay, what's it going to look like if I make that negative? Well, it's just going to flip that thing upside down. See, the vertex is always right here. It's whatever makes this 0 plus or minus this, okay? So this is going to be negative 3 is going to make this 0 right here. Boom, that moves it 3 to the left and then up 2 right there, and then that flips it upside down. Okay? Again, if you're not sure, test it. Make a table. Okay? So if I plug in negative 3, I'm going to get negative absolute value of negative 3 plus 2. Well, this is going to be 0. Negative 0 is just 0. Plus 2 is 2. So I plugged in negative 3 and I got 2. Oh, there's my vertex. What if I plug in negative 1? Well, that's going to give me negative absolute value of negative 1 plus 3 plus 2. So this is going to be 2. Absolute value of 2 is 2, so this is negative 2 plus 2, which is 0. Negative 1, 0 right there. What if I plugged in negative 8? That's a terrible negative 8, isn't it? Negative 8. Okay, to have negative absolute value of negative 8 plus 3 plus 2. This is going to be the absolute value of negative 5, so it's negative absolute value of negative 5 plus 2. Well, this is going to be 5, which makes this negative 5, plus 2 is negative 3. So I'm going to get the point negative 8, negative 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Sure enough. Okay. Oops. All right. Now, what happens if I put a number out here in front of the absolute value? Well, this number out here in front of the absolute value ends up being the slope of the sides. So all of these that we've done out here have just had no number out here. There's really a 1. Okay, there's a 1 here, there's a negative 1 here. Okay? Here we've got a 2. So what this is going to do, my vertex is going to have an x-coordinate of 0. It's going to be moved down 5, but the sides are going to have a slope of 2. They're going to rise 2 and run 1. So it's going to look like this. 1, 2, 3, 4, 5. Right there. Now, that got narrower. It's got a slope of 2. It rises 2 and runs 1, rises 2 and runs 1, rises 2 and runs 1. And it's got a slope of negative 2 on this side, so it goes down 2 into the right 1. Down 2 into the right 1. Okay? So this number out here is the slope of the sides. And of course it's going to be positive on one side and negative on the other one. Okay? Because you always got to make the V. Now let's try this one on your own. So pause the video here and try y equals negative 1/2 absolute value of x minus 3 plus 5. Okay? And see what you get. Okay, so what's this thing going to look like? So the vertex, which we always start out at 0, 0, is going to be moved to 3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. It's going to be right here. It's going to be upside down. It's going to have a slope of 1/2. Okay, so it's going to have a point here, and a point here, point here, and a point here. So my graph, meant to have an array. It's going to look like this right here. There we go. Let's see if I hid that thing back there. No, apparently not. Okay, so that's what your graph should look like. So when I have a number out here that's between 0 and 1, that thing's going to get wider. Okay, if this number is bigger than 1 or smaller than -1, it's going to get narrower. Okay? Okay, here's your assignment. I'll have a worksheet for you in class. But there's your assignment. You got 24 problems to do. Shouldn't take you too long. I will see you guys in class. Have a great evening.